Assalamu alaikum. Um, I welcome you all on the second session of our talk on role of pathology laboratory in the present pandemic, that is COVID-19. So we will discuss some more aspects of pathology laboratory, which is involved in the diagnosis of this disease. Since the situation is evolving every day and we get new material and there are new findings, so uh, we are trying our best to keep ourselves uh, keep ourselves abreast with the uh, changing situation. As I said earlier in my first presentation, we have no conflict of interest. We will take names of some proprietary and some firms, but without any prejudice. Our purpose is uh, to disseminate information about various products to our users, to our pathologists and senior laboratory persons. In the present session, we are going to divide the talk in 5 segments. First will be of laboratory biosafety because it's very important. First of all, it's our duty to protect our staff and our community, our environment from the infective material. And secondly, we will discuss some aspects of specimen collection. Then few technical things, which is the PCR technology, we will also discuss it. And then we will touch upon the serological testing. And lastly, we have a guest speaker, Mr. Rana Shoaib, will enlighten us with some aspects of the disease testing. We will use the mute all options uh, during the each segment, and then we will unmute for question and answers. Our ultimate aim is, of course, making a PSCP guideline, Pakistan Society of Chemical Pathology guideline for the use of all any person in the world who want to get mm, some awareness, some guidance about the laboratory testing of this disease. It may contain some clinical, but of course a lot of technical material, and we will also try to include the information about the public sector in various labs in Pakistan. Since the situation is, as I told earlier, the things are changing very rapidly, and we will do all our efforts to keep ourselves at pace with these changes. So laboratory biosafety for COVID testing is very important because first question is which laboratory we should use. As I mentioned in my first talk also, the WHO in its latest guideline of 2020 about this disease, the WHO has recommended BSL-2 lab. There is no discussion, no controversy about it. I've also confirmed it from the very highly expert people of biosafety in Pakistan who work in NIH and other places, and they have confirmed that the lab required is BSL-2. It is not BSL-3. And in BSL-3 lab, if we are doing PCR for COVID-19, we will have 3 portions, 3 rooms. One is region preparation. This is a clean room. Then extraction room, which is potentially the most infective area, and amplification room, where the infectivity of sample which after extraction, which contains RNA, uh, it, there are chances that it is not infective, but we do not know for sure. So all precautions should be taken during amplification too. So first is this reagent mixing room, or we call it clean room because uh, there is no, there should be no DNA from anywhere in this room. Thank you very much. The first stage is reagent mixing, and it is called clean room because here we want to avoid any contamination of our product. That is the RNA which we want to test. So there may be human contamination of the DNA or contamination from other organisms. So in this room, you can use just your laboratory bench, or you can use a, a fume head or a working station. This is not biosafety cabinet. The second stage is extraction room. It is very critical, and here you will place your biosafety cabinet, and the initial sampling from the patient sample is done from right inside this cabinet, and whole full PPE should be worn, which includes this yellow is bodysuit, gloves, face mask, and face shield or goggles. And although when you are working on the biosafety cabinet, you can see the glass is below, well below his face. Uh, Still, we'll recommend that the worker should not remove the face shield or goggles, because he may, when he will stand up, yeah, then he's exposed to the biohazard. So full PP, full precautions should be taken in extraction room. Now, a word about biosafety cabinets. I know some people are masters in it, and they know a lot more than I'm going to tell to you. But this is for the beginners. Biosafety cabinets. What is biosafety cabinets? It is an enclosed, ventilated laboratory workspace areas designed to protect the user and surrounding environment from pathogens. Uh, there is a very important part. If I say most important part in a biosafety cabinet is the HEPA filters. HEPA means high efficiency particulate air filters. The HEPA filters, they trap viruses and bacteria. And biosafety cabinets can be of class 1, class 2, and class 3 classes. And when you write class, you write these Roman letters 1, 2, 3. The class 1 is very basic, and it can be used where you have the least danger of contamination. And class 2 provides protection for the user, environment, and sample. So 3 protections: user, environment, and the product. Class 2 is divided into A1, A2, B1, and B2. It is according to the inflow of velocity and other technical things. So class 3 is boxed glove box, in which, if you have seen in a picture, that two gloves box, the two gloves, they come out of the go inside the biosafety cabinet and work. So you do not even put your hand in class 3. So what class of biosafety cabinet is recommended for COVID-19? This is, I think, a very important part. It is called class 2 type A2 cabinet. The biosafety cabinet to be used for COVID-19 PCR is recommended to be class 2 type A2. Uh, of course, it will have a HEPA filter, and the airflow, which is inflow, which determines, which is defined, is 100 feet per minute. And the air filter, now there are two options. You can filter the air back into the laboratory or outside. The better method is to filter it outside the lab. And everything should be done inside the cabinet. And how to check whether your biosafety cabinet is working or not? Very simple thing. Either you procure liquid nitrogen fumes or any other less dangerous fumes, and you can place here, and the fume should go inside this grid, so that then you confirm that the biosafety cabinet is actually working. Third room is called amplification room. Again, it is not that contaminated or infective, and you can here you place your this thermal cycler, whatever thermal cycler you are using. There are other small tubes and cuvettes and all those things which we will discuss shortly. they are placed in this stage 3 or room 3. So summary of lab biosafety is major requirement of BSL2 lab is biosafety cabinet of class 2 type A2. Extraction room is the most infective area and there should be controlled entry. And it is better to make a PP change room just outside these 3 rooms so that when the person enters into extraction room, he is already putting on those PPEs. So anything you can do, either you can use a corridor or a separate room. And second thing, if possible, there should be dedicated washroom for this lab because when the worker will come out to use washroom, he cannot go to the other parts of the lab. So any question, the mics are open. You can ask questions.
उसके बाद तो काटे पड़ी है 7 ज़रब 3.5
जी क्या कह रहे हैं
7 ज़रब 3.5 लिख बाटा ने भैया ने देखो हम लोग दरवाजे से साफ पड़
भी मैंने अब अनम्यूट कर दिए माइक प्लीज ऑल द माइक्स आर अनम्यूट फॉर क्वेश्चन आंसर्स ओनली इफ यू हैव एनी क्वेश्चन अनम्यूट योर माइक अदरवाइज कीप इट म्यूट डॉक्टर महनाज उमर your Dr. Mamoona Zia, please mute your mic. So I think there are no questions. You can ask question afterwards also.
Aamir, what about the availability of the class 3 in Pakistan at this moment?
Class 3 is not required, Asim. Class 3 is not required.
I'm just asking for them.
Alhamdulillah, they can supply you. No problem, because you have to place order. And class 2A, class 2 type 2A, they are making, I'll tell you in the later part, NDML is also providing this type of cabinet.
Okay.
And all these cabinets can be imported if you place order, but of course not in this time, because in these times there are problems in the cargo flights and supplies are very erratic. So I don't know how much time they will take if you place an order for class 3.
Because there was one opinion from the microbiologist who was saying that there is a requirement of the class 3.
No.
For the...
this I can contest because I have observed it, I have asked it, I have confirmed it from the highest resources in NIH. I've asked from the commandant NIH also, who's the most expert person in biosafety in Pakistan, and Major General Aamir Ijaz, and he has also said that it is just the biosafety cabinet to class 2A. Okay. But if you have any reference or anything, please ask that microbiologist. May be wrong. There may be some other recommendations. So nobody can be final.
I think it's class 2, mostly they use class 2A, but I just wanted to clarify it.
Okay. Now we go to the second segment, which is the which concerned with the specimen collection. I already sent you the presentation shared by Dr. Roma Sherili from SIUT. She volunteered this presentation, but I thought I must discuss some important points because I think this is a very, very vital. This is a vital aspect of our testing. So first of all, if you have not yet started the facility of PCR, first of all, you should design a proforma. The proforma should contain patient particular with at least 2 identifiers, which is the international standard. 2 identifiers means patient name, age, or some MR number, or some address. And in Pakistan, you must add CNIC numbers and mobile number. These two information, they are very important. CNIC number and this your mobile number. Why? Because if you are doing the test, you have to report somewhere. You have to send a return to the authority, either health profession education or to NDMA, and these two things, they are essential, and CNIC and mobile number of the patient, so that they may contact the patient directly also. Then clinical features should be noted. And last thing is, what is the indication of the test? Any symptomatic patient having fever, having upper respiratory tract symptoms, we all know what are the symptoms. So he's a candidate, he or she is a candidate for the test. History of contact with COVID-19, which I referred in my first talk as track, test, and uh, quarantine. So for that, in that policy, you have to test. Recent foreign travel, it's still all good. Although its importance has been reduced because now our local cases, they are outnumbered. They are about more than 50% are local. But still, if there is a foreign travel, this is an important information. Healthcare worker, I think this is my personal opinion and opinion of many other people. Any healthcare worker, he has a right to get him or herself tested, because he may be in direct contact to the patient, or he may be working in an area where patient has passed. So I think we should stress, emphasize to all authorities that any healthcare workers, they have the right to get themselves tested, himself or herself tested. Pre-surgical screening, it is a new indication now coming up. Surgeons, anesthetists, they are now demanding the pre-surgical screening for patients, and they are very right. It is also an important part of the biosafety, and this is also important because if the patient is COVID positive, and at the moment of it is he or she is asymptomatic, but it has been seen that in the recovery phase or after surgery, they get complications because of this disease. So testing for in pre-surgical patients is important for the surgeons, anesthetists, and OTA staff also, and for the patient, him or herself also. And lastly, random testing, I call it Farmaishi testing. So now the government is also saying some words about random testing. I tell you, according to my information, now government institutes have got plenty of ample amount of kits, PCR kits, and they now want to create facilities for that. They want to give assurance to the public or patients that this test is essential. So maybe random testing will become more frequent these days. What types of specimen? Oropharyngeal, nasal mid-turbinate, anterior nares, they are the commonly used samples. There are now concerns about the nasal samples, mid-turbinate or anterior nares, because patients sometimes get irritated. He may sneeze, or he may has other symptoms. So people are now avoiding, and they say it is not that useful because virus quickly travels to the oropharynx or other parts. So it is oropharyngeal is now is more commonly taken. So you can use both of them, oropharynx and anterior nares, or you can use oropharynx only. Tracheal suction is a very good thing, because suction is usually carried out in admitted patients, in patients who are not well. So you can take a small sample from the tracheal suctions. A lower respiratory tract, as I mentioned in my first talk also, it's a very good sample with the high yield. But of course, bronchial lavage is not an easy thing, and it's again an hazard. But if somebody has done bronchial lavage, you can use the sample. Urine stool, there are talks about the spread of the virus in the gastrointestinal system, and people are saying that this virus can resist the low pH of the stomach, and you can find it in stool also. The PPE for specimen collection, again, very important. Specimen should be collected with And you should advocate for this PP. You should not compromise for the safety of your staff. There must be N95 gloves, face shield or goggles, and bodysuit. If bodysuit is not available, then such type of gown can also be used. Then another part is collection, transport, and storage of the sample. Uh, a very important part is that synthetic fiber swabs with plastic shafts should be used. Wooden shafts should not be used because it is said that wood inhibits the bacterial growth. Do not use swabs with a wooden shaft as they may inhibit PCR. Okay, leave swab in place for several. Now the technique is that when you put your swab on the palate or on the tonsils or in the oropharynx, then leave it for few seconds there, and then you rotate the swab and rotate the swab inside, and then slowly remove it, and then put it in the viral transport medium, VTM. VTM is, I think, one of the most selling substances, medical uh, thing these days. This is the tube of VTM, and this is a viral transport medium. And if you have taken two samples, nasal, you have taken nasal specimen and oropharyngeal. You should, it is not main. You should place it in one VTM because they will uh, they will they will mitigate, they will enhance the growth of the virus inside. And you can place the specimen for 2 to 8 degrees centigrade for chipping. It is said that sample survives 48 hours at this 2 to 8 degrees centigrade. And if you have to store it for longer time, you should place it in much lower temperatures, maybe at -70. So proper training is required. I always uh, say that the most important cause of false negative is improper sample. You may be having hi-fi technique, you may be having very good PCR system, but if your sample is not properly collected, the result will be false negative. Okay, ji. Now we come to the more technical topic, which is the PCR technologies. What are the various technologies which are used for the detection of PCR? For my younger colleagues and for the beginners, what is PCR? It is polymerase chain reaction, and it is best known and widely applied of the target identification methods. If I usually ask one question, in one word, can you tell me what is PCR or what is polymerase chain reaction? I ask this question usually to my students. Please tell me in one word what is PCR. So that one word is amplification, amplification and amplification, nothing else. So actually PCR allows a single DNA or RNA sequence to be copied in millions. It's a photocopier. So there can be millions of copies. I thought we must give credit to this doctor, this researcher, this scholar, uh, Dr. Carrie Banks Mullis, who won Nobel Prize in Chemistry in 1993 because of his wonderful uh, discovery, wonderful improvement in the technique of PCR. PCR was there before this discovery, but it was a tedious process. Uh, some of my senior colleagues have told me that the old timers, of course, that previously the PCR used to take hours or days because each step has to be carried out separately. So what Mr. Carey Mulls has done, or Dr. Carey Mulls has done, that he has made the PCR so simple that it can be done in any lab, and in this disease COVID-19, we must give credit to these gentlemen, these scientists. Had there not been this discovery, I don't know what method we would be using for the final diagnosis of COVID-19. So thank you, Mr. Dr. Mullis. Now, these next 3 slides are from my previous presentation, and again, it is just to refresh your the memories or knowledge of the junior colleagues. The first step in any PCR is denaturation, in which we increase the temperature to nearly 95 degrees centigrade, so that the two chains of DNA, strands of DNA, they are separated. How they are separated? Why it is called denaturation? Because the hydrogen bonds between these two chains, they break, and the two chains are separated, or and then we can use each of them for further process. Second step is the annealing. Annealing is actually binding of some nucleotides to the single strand of DNA. This is called annealing, and for annealing we have to lower the temperature nearly 50 to 60 degrees centigrade, because at high temperature these nucleotides will not be attached to the strands of DNA. These nucleotides are called primers, and primers are of utmost importance in the process of PCR. And primers, you have to order primers, or you have to make yourself the primers. So another important thing in PCR is that you should know the sequence of nucleotides which you are going to amplify. If you do not know the sequence, you cannot use this technique. So this technique is valid only when you know exactly the sequence of RNA or DNA you want to amplify, and accordingly the primers are made. The third step is extension. Once again, we increase the temperature around 75 degrees centigrade, and in extension, our hero, the polymerase, is used. Now, polymerase has to survive a temperature of 75 degree or so. So, since enzyme polymerase, how can it survive such a temperature? Normally, enzymes or proteins do not, they get denatured at this temperature. So I think the most wonderful, most important discovery was the bacteria, the Thermus acutus, which was found in the hot springs of the Rocky Mountains district in the United States. And they found bacteria in the hot springs which can survive there. They named it as Thermoequatus, and their polymerase, because polymerase is present in all the organisms, because all the organisms have got either DNA or RNA. So from there, the polymerase was extracted and used for extension. And now you can do it in one go, that uh, uh, denaturation, annealing, extension can be done just by changing the temperature. First, very high temperature, then lowering the temperature, and then increasing the temperature once again. Now, PCR for SARS-2 COVID-19, that means the viruses which we are dealing with, it is a different, altogether different than the human DNA or other DNAs. Two important modifications we will discuss today. First is the reverse transcriptase, which is denoted as RT. And second is real-time PCR. Well, again, it is RT, but usually it is written as small r and small t, or just small r. So I don't know who has made these abbreviations, but generally it is said if capital RT is written, it means reverse transcriptase, and if small r or small rt is written, it is real time. So let's see what actually it is. Reverse transcriptase or RT-PCR is making of DNA from RNA. What is the most important thing is that we have to make first DNA from RNA, and this DNA is called complementary DNA. It is in vitro, in the laboratory. In the laboratory, we make complementary DNAs, and then we carry out Again, those three steps on complementary DNA, that is denaturation, annealing, and extension, and about 40 cycles, usually 40 or so cycles are carried out. And with this, after this cycle, we get the result, an S-shaped curve, which indicates presence of RNA viruses. And you'll understand this. Don't worry, I'll explain it to some extent in the subsequent slides. So first, we will discuss what is actually transcriptase, reverse transcriptase. A normal, the DNA elongation or DNA replication is, you know, it is called transcription, and messenger RNA is made from DNA in the cells. And in the laboratory also we make, in the laboratory, if we want to do some experiment on RNA, we have to make RNA using the transcriptase. But in reverse transcriptase, RNA makes DNA. So in transcription, DNA makes RNA, and in reverse transcription, RNA makes DNA. The steps, there are about 5 steps in it. First is annealing. No, this is so that's why it is a little bit different from the usual DNA PCR. First, the first step in this process is annealing. So the primers which we have used, they will get attached to the RNA, and in our case it is viral RNA. So primers will be attached to the viral RNA, and the temperature here requires is lower, about 50 to 55. And from this process, we will start making complementary DNA. There will be synthesis of complementary DNA because of the reverse transcriptase. So reverse transcriptase will start making complementary DNA from the primers. When complementary DNA are synthesized, the RNA, viral RNA, will be destroyed, will be vanished by an enzyme which is called RNase. Now we are left with the complementary DNA. Now the same process of PCR will start, which we discussed earlier. That means denaturation. That means the separation of the two DNA strands, and just because of the high temperature, the hydrogen bond between the two strands that melts away, and the two strands, they get separated. Second is annealing, which is because of the lower temperature, and the primers is attached. Actually, in fact, there are two primers. One is attached on the one strand at 3, and since the second strand is lying up anti-parallel to this, it's 3 prime end is on this side. The primer will be attached on this side, and then DNA polymerase will be active, and it will cause elongation of the curve. The elongation of this strand, and the with nucleotide getting attached to it, and two strands will be formed. So by this process, reverse transcription, we make complementary DNA, and complementary DNA by the 3 usual processes of denaturation, annealing, and amplification. Will first one DNA strand, one DNA will make 2 DNAs, and from 2 DNAs, 4 DNAs, and from 4 to 8 DNAs. What is actually needed for this procedure? Of course, we need RNA. If the virus is there, virus RNA is present, we add primers, we add reverse transcriptase, and we have to add the transcription material, which is DNTPs. What are DNTPs? Simply, DNTPs are the nucleotides, the 4 nucleotides you all know, and because these nucleotides will be attached to the to make the chain of DNA, and then polymerase enzyme, which is used for the elongation. Now we come to the what is real-time PCR or real-time reverse transcription PCR or RT-PCR. Real-time PCR is another technical revolution. It's an excellent innovation. We use fluorescent label oligonucleotides. Commonly used probe is TACMAN. In the DNA, usually we use sign green, but here we use a very specific um, probe, which is used. For example, if we are doing the reverse transcriptase for real-time PCR for this COVID virus, we have to use specific, very specific nucleotides and specific probes. That is called TACMAN. So TACMAN is added for this is an additional thing, and the fluorescent dye commonly used is known as FAM. FAM is the actual fluorescent dye which will emit light when it is uninhibited. What is this? I'll just let you know in subsequent slides. So before becoming part of the complementary DNA, these fluorescent labeled nucleotides are attached with cancers, which keep the fluorescent fluorophores inhibited. This is in next few slides, I will try to explain what actually is the real-time PCR. So first see this TACMAN or the probe. This is a reporter, it's also called reporter. This is also called probe. And here what we are using is TACMAN. So in TACMAN, the fluorophore is attached to the nucleotides. These are the nucleotides, which means cytosine, guanine, etc. And the other is the quencher, which keeps this inhibited. If it is quencher is attached, the fluorescence the fluorescence will not occur, and it will remain silent. So what happens that this probe or TACMAN will first attach to the DNA, the complementary DNA separated strand, which we are using now. So it will be attached to the either of these strands, and what will happen next? That when there will be primer added to this, and there is elongation of the strand because of the polymerase enzyme, this fluorescent label will be separated. And when it is separated from cancer, it can start emitting light. It will start fluorescence. It will start fluorescing. So, and this light is we will use for the detection. As the number of copies of DNA increases, the fluorescence which was attached that get released, and with the passage of each cycle, if RNA is present, and the number of copies increase from 1 to 2 to 4 to 8, the fluorescence signal will also increase. So this is a very nice graph, and this actually tells us how to interpret the result. You see, as the number of cycles increases, the fluorescence light, fluorescing light, its quantity is also increased. There is also a unit which measures the fluorescence, which is called RFU. So this graph is between the RFU and the number of cycles. So as the number of cycles increases, the fluorescence also increases. So there comes a point when the fluorescence, the amount of light which is emitting from this fluorescing substance, it suddenly goes up. So if this is our threshold of, we have put a threshold that so much light is required for to be generated in this particular assay. So the point where this curve touches that threshold line is very, very important in our assay. It is called cycle threshold, CT, cycle threshold, or some people call it CQ, but more commonly it is called CT. So it is the, how you define CT. What is CT? CT is the number of cycle when this curve of light touches this threshold line. Okay, and as the exponential phase continues and the light goes on increasing and increasing, there comes a point when no more increase in the light occurs and a plateau comes. So that's why the shape is S or sigma shape. So this sigma shape is very, very important. And you will say the result is positive only when if the shape is sigma. If this curve is flattened like this, the result is not valid. For valid results, the curve has to be S shape or sigma shape. So why it is sigma shape? Because the light increases and then a plateau comes and no more increase in the light occurs. This is a slide I've shown you to give an idea of, we can also make it a quantitative PCR. How we can make it quantitative? Just bear with me. You see, there are various samples which have been run in this assay. So every sample has got different curve, but all are positive because all are showing S-shaped curve, typical sigma shape S-shaped curve. But if you concentrate on this very first curve, this curve has started just after 3 or 4 cycles. And the CT in this very curve is very, very low. Just after 4 or 5 cycles, it has touched the threshold line. Whereas in this particular sample, it has touched the threshold line nearly at 28 cycles. So what does this mean? This means that in this first sample, the amount of DNA is very, very high. And if the amount of DNA is high, of course, the amount of RNA is also high. So the viral load is high. So you can also get an idea of the viral loads in RT-PCR or this PCR, this real-time PCR. So, so this is the highest quantity, and this is the lowest quantity. In every assay, you will also find a minimum number of cycles. Usually it is called CT number. So CT usually in the COVID PCR, the CT is 32. If the CT is more than 32, usually they say this your test is not valid. So to give a positive result, it should be less than 32. That means it should have touched the threshold line before 30-second cycle. So if it is touching after 30-second cycle, probably the result is not valid. Another point I want to tell you why it is called real time, because the results start coming up just after first cycle. Although we complete 40 cycles, but you can observe on the screen what is happening, if the curve is rising or not. So that is why real time. What was before real time was the manual sort of PCR. In that particular PCR, we had to wait for completion of the PCR cycles, and after completion, we would do a gel electrophoresis, and then only we can see what are the results. So it is real time because you can see the fluorescence occurring, fluorescence light coming out just after a few cycles, and the curve going up and up and making an S shape. Now coming to the RNA extraction, actually this is the number 2 step before amplification we do, as I told you earlier. Uh, uh, there are two methods used for the extraction. One is the manual method. It is time consuming, more hazardous, but it is very cost effective. Approximate cost at this point of time is about 250 rupees per test. Whereas auto extractors, they are also commonly used. You can see in this picture also, this is the auto extractor and it is out of safety cabinet. It cannot be placed in safety cabinet. And it is very safe, but the cost per test is higher, nearly 650 or 700 rupees per test. This is for at this point of time. Now, how we interpret data. Now, coming to the actual laboratory uh, laboratory data. These two images are from my own lab and the actual patient samples. On the right side is called internal control. Actually, it is something like the internal standard which you use for the techniques like HPLC and GCMS, etc. So for every sample which you run in PCR, there is an internal quality control, which is part of the regions. So for every sample, you can examine the internal control. There should be a typical S-shaped curve for every sample. If there is no S-shaped curve for any sample, then the test is that particular test is not valid. So this is for our own internal consumption. On the left side, the screen on the left side, it shows the two things. The gene which we are using for this particular assay is ORF1 AB gene. I told you in the first lecture, you can use any genes, and when there is pandemic, you can use one single target gene also. But if there is no pandemic, then at least two genes should be targeted. And you can use two genes, no problem in any PCR. So on the left side, you can see there is only one curve which has shown as typical sigma shape and which has come nearly at the 30 before 30th cycle. And this curve is actually positive control. These are external control. This is positive external control. All these other samples, they are not showing any curve. There is no fluorescence. Why there is no fluorescence? Because there is no RNA, there is no virus. So when there is no virus, no RNA, no complementary DNA has been formed, and no fluorescence has been produced. Only one sample has produced fluorescence, and which is actually the external quality control. Similarly, an internal quality control is also used, but and it is simply a blank sort of region, and it should also be showing a flat line. So I hope you understand that for each sample, you should examine the internal control, and you should also see the results of the external positive control and external negative control. Thank you. Now, various types of real-time reverse transcriptase PCRs are used. There are small thermal cyclers. Similar, we are using this thermal cycler. This is made in Australia. The tubes are very small, about 50 microliter tubes, 40 to 50. And in these tubes, we add 30 microliter of the master mix, which is a mix of two reagents. One is enzyme, and the other is other components, which include uh, the, the PCR materials and etc. etc. So and extracted RNA, about 20 microliter we add in it, and we put all these samples. We can use, this is a 48 channel PCR, and we can do 46 patient samples, because two slots are for the in external quality control, negative and positive. Similarly, larger thermocycles are also used. Probably they were the the first generation thermocyclers, and you must have seen these. They're I don't know the comparison. Anybody has done comparison between the two types of thermocyclers? Then there are now fully automated systems also. For example, Cobus 6800, which is a product from Roche, of Europe. It is being used in Al Shifa Hospital. Al Shifa is using as a part of TLA, which is wonderful thing, really wonderful, because it is the same line, same chain, which is doing the glucose, same chain which is doing the thyroid, I mean amino assay, calorimetry, and the same in the same chain they have put the instrument for PCR, and very good results they are producing. Similarly, in DAW also they are using Abbott. No, sorry, this Cobus 6800 from Roche. And since their RTA is their TLA is different from Abbott, so they are using as a standalone. The Roche PCR system is used as standalone. Abbott has also launched its real-time PCR M2000, which was previously there, and they were using it for other influenza viruses. But recently, on 18 March, they've got the emergency use authorization EU from FDA for COVID-19. In Pakistan, I really don't know whether M2000 is used or not, but I have unconfirmed information that such instruments are used in Indus Hospital, Karachi, but I can't confirm it. Then, more recently, Abbott has launched another wonderful thing, which is called molecular POCT. That means the PCR, but with POCT. That they have also got an emergency authorization from FDA, and but currently they are not flying out outside USA. Otherwise, there would have been a lot of customers for Pakistan demanding this instrument. So positive results are given in 5 minutes, negative results are in 13 minutes. I'm a part of the discussion forum, which is called Artery from American Institution of Clinical Chemistry. And these days I'm getting a lot of emails from them. People are discussing about this ID now. Some of them have reservations that very few positive results are coming. Others are satisfied. So I don't know what is exactly validation report of this instrument. Now, a few words about the use of the pool sample. A lot of literature is coming. People are asking us whether we should use pool samples or not. We can't say anything about it because there are some reservations also because of the LOD. LOD means limit of detection. Some PCR system may be having higher LOD. So if you are pooling the sample will be diluted, and it may be lower than the higher than the LOD, which that particular system is using. Similarly, the clinical sensitivity of the assay is said to be 70%. So if you are using pooled sample, what will happen to the false negatives? There may be increased false negatives. So currently, it's still a fluid thing, not a decided consensus on using the pool sample. Some people are using pooling of just 3 samples in situations where there is larger population screening. For example, if you have to screen 250 or 300 air travelers who have just come, so you may use pool of 3 samples, and if all 3 are negative, you can clear them. Now, what is way forward? Way forward is partnership with NDMA. NDMA is National Disaster Management Authority, currently headed by a serving Lieutenant General Afzal. And General Afzal is a remarkable person. I had a meeting with him, and they offer PCR systems and reagent kits free of cost. So any laboratory, any hospital which convince them with would approach them and show their interest for the system, they will provide it. The system, they will also provide N95 and goggles, and currently they do not have the viral transport medium and extraction kits, but they say in future they will have these material also, and they may have also provide biosafety cabinet. So if you are just planning to start a PCR system and do not have biosafety cabinets, you can also approach NDMA for all this equipment. So private and public hospitals can approach NDMA. The purpose of Pakistan government authorities is to enhance the number of tests. By any means, we want to enhance to maybe 50,000 per day, or I don't know the exact figure, but it is said that as we increase the number of tests per day, we will be more conversant with the methods of controlling this disease. So in summary, I will say that real-time PCR is the most optimum and widely used test for COVID-19 all over the world. When WHO says test, test, and test, it means PCR. So approach NDMA for partnership. Thank you. Now, any questions? I will unmute the mics and you can ask questions.
Thank you very much. Assalamu alaikum, everybody. Thank you very much. Very informative presentation, Dr. Ijaz. I'm
Thank you. Thank you.
Really impressed, and I've obtained a lot of knowledge. One comment: when you said the internal controls are carrier nucleic acids, they are used throughout the whole process,
yes,
starting from extraction to the detection mechanism.
Yes.
However, for external controls also, sorry? Oh, okay. There's a background noise. The external controls are also now becoming available with the certified number of copies inside of each vial. You can dilute them and you can use them for the whole process, including extraction and detection as well.
Okay, okay.
This is much more safer mechanism
Yes,
because
yes,
internal controls provided with the kit certainly have certain additives which enhance or boost the performance artificially.
yes.
So those are the controls to validate. Internal controls or in-kit controls are there to validate the kit contents. Whole process can be validated with the use of external controls with the known number of the copies of all the targets, or
Yes,
whatever your strategy is. And then you can compare the recovery on that particular batch versus the recovery of your external control.
yes, very nice. It's a very important part of technical information. And so what Mr. Schwab has said, I'll repeat, maybe somebody has not comprehended it, that the internal control and the external controls, they should be part of your extraction process also, because these controls will tell you if your extraction process is adequate or not. So that is the crux what he has said. And thank you very much. And we will, everybody should note this information and adopt it. Secondly, the LOD. I have not touched this topic, LOD, because the kits which are available these days, especially of these smaller systems, they do not give LOD, and we have to accept it without this parameter. Although the bigger companies, and by the way, Bio-Rad is also a very good company for PCR, but unfortunately, their systems are not coming out of United States because of crisis in US itself. So these companies, they give all those parameters of method validation, LOD, etc.
Sorry for interruption. Well, when you said that Bio-Rad systems are not being made available, please refresh the information. As of today, we have received the orders from NDMA for 20 or plus units. 2 units have been delivered yesterday.
Do you have the kits also?
Yes, C-Gene kits are being.
I've heard that you have got the system, but there is problem in the supply of the kits. But
yes, of course, supply is a big problem.
Yes, that's what I'm saying.
But
if you are part of the NDMA system, They will also facilitate your cargoes, and you will get smoother supply chains. So
Yes, we
it's a
truly
wonderful
understand.
news. And now this is again, if 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 NDMA has got Bio-Earth system, this is wonderful. And I repent, why couldn't we get this Bio-Earth system? And you must now approach NDMA, and you may get this because Bio-Earth, of course, very superior system, and they will be having information of method validation like LOD, etc. Now a word about LOD. What should be the LOD, lowest limit of detection? That is usually less than 100 copies per ml. And in terms of microliter, it is at 1 to 5 copies per microliter. So Abbott, etc., and Roche and Bio-Rad, they give you this their LOD, their claimed LOD, and that makes you more confident. So if no more questions, should we go to the next part?
Amir, just one comment.
Please.
I just want to share with my colleagues that some of the laboratories in the Lahore who are performing or not performing, the technical staff over there, they have refused to work to deal with the samples if they are receiving any corona patient. And they must be clear in their mind that through blood, it cannot be transferred to them. That is their point of view. And it has been very cleverly clarified to them, but it should be encouraged and taught to the technicians that it will not spread to them through this route.
Okay, thank you very much, Asim. I think it's a wonderful point, and we will include it in our final document, PSCP guidelines. Until now, as of today, coronavirus doesn't enter the blood, so it is not part of the blood system. So we should encourage our students, our laboratory staff, that it is not part of it. Okay. So now we go to the next part. It is the serological testing. Serological testing, I talked about it in my first talk also, that serological systems, we must keep ourselves abreast what is going on in this field. Currently, the qualitative device, they are being procured, people are getting it. This is the typical ICT device. It has got 3 lines or 3 parts. One is control. If this line appears, it shows that your system is okay. G is for IgG and M is for IgM. But PHC and NIH and other authorities, they have banned use of these qualitative devices, very rightly, because our smaller labs or our clinics will make money and will use it. That's why it is banned for use for diagnosis. But as I said, we must keep a track on what is going on, what are the developments. So one very important use is IgG titer, and in following situations. For example, determining the immunity in future when this epidemic is over or nearing its closure, then we will require the IgG titers to see whether our people are immune or not. Have they developed enough immunity? And there are talks of convalescent plasma, so we can use it for that purpose also. And after vaccination, hopefully when the vaccination will be available, then like hepatitis vaccine, we may order a IgG test to see enough protection has been created or not. Currently, quantitative serological tests are made available, not qualitative, quantitative. One is based on immunofluorescence, and the company's name is Lifotronic. You can see the name. This is a UK company, UK-based company, Lifotronic, and it is a POCT, but it gives quantitative results of both IgG and IgM in 15 minutes. Then Chinese friends have launched chemiluminescence-based IgG and IgM on megalumi, and the company name is Snipe. currently there are issues in logistics or some issues in supplying of these kits to Pakistan. Probably, I don't know the actual cause. Probably there is a shortage of flights or etc. Then chemiluminescence, the wonderful technology, is also used in the Abbott. Abbott has got another EUA emergency authorization for their own IgG, IgM kits on chemiluminescence. 3 more companies have got emergency FDA approval for these kits, and you can see their names here, and they will be available in the market. So gammary about the serological kits, we should keep a track of the developments in this field. In the later part of the pandemic, these tests will gain more importance. China has already started them, but we should abide by the PHC, NIH, and other regulatory bodies, and we should not do these tests for diagnosis. Now I'll invite Mr. Shoaib Rana to give his talk, please. I have unmuted all, but please keep your mics shut and let him give his. Please, Mr. Shoaib.
Thank you very much, sir. I'm not very expert, not expert in the computer, so I'm not seeing what people are seeing. But probably, can you see my desktop?
Okay. I'll share your.
Is it possible to share my desktop?
DG, please, you share from that side, from your angle.
You cannot start screen share.
You please carry on, it's visible.
You have to close sharing yours first, and then I can share.
Okay, I'll stop. Now you share.
Thank you, sir. Thank you.
Yes.
How can I go? Sir. Thank you, sir. As everybody knows, my name is Shoaib Rana. I'm from Chemical House and represent Resident Laboratories in Pakistan. And my role in blood virus diagnostics started in 1993. Since then, I've been working on ELISAs and PCRs. In 1998, we brought PCRs and the real-time PCRs. So a little bit knowledge is available to me also, and I've tried to share some of the information which are real concerns today. And I've failed to understand, I failed to find the right people, I should say, to be able to discuss these concerns and highlight the areas where we have some gaps. So please correct me wherever I'm wrong, and please advise me the right direction also, so that the message goes forward if it is a correct message. So in Pakistan, our preparedness, first of all, was a missing link. Like everybody in the world was not prepared for this kind of a huge crisis globally, and everybody started to face it. Let's go to Pakistan. The lockdown started on 21st of March 2020. And the first case was reported on 26th of February. This was not the case zero in Pakistan. Of course, the case zero was before, because on 26th of February, Pakistan developed the ability to test for coronavirus for the first time, and they reported tests. Many scientists suggest that it arrived, the coronavirus arrived in Pakistan in the early January, but that is still a debatable date. And we can certainly assume that it arrived way before 26th of February. Now, if it arrived way before 26th of February, definitely we had a great spread. And we don't know how much has been spread, and where should we go from now? Of course, Dr. Ijaz has very rightly highlighted the use of the PCR technique, which is fantastic, but we should really consider some more parts of it in depth. So going from here, the current data after 46 days of the first report, we still have less than 100,000 tests done. It's very limited data. And false negative and false positive results are a big issue, because initially some labs missed the protocol and also used inappropriate samples. yes, the limit of detection, which Professor Ijaz has already highlighted, is a big issue, and the quality of the kits coming in. I'll address some of the issues in the slides.
Uh,
But
these
sorry,
slides are not visible.
slides are not visible?
Yes, when you just highlight it on the lower cursor to increase the size of the slide. Slide is visible, but only one slide is visible. Now,
Is this better? Is this better, sir?
no. You just do it. Okay, carry on. It is better.
Please do this slide show. That will be giving full view.
Is this better?
नीचे bottom line में ना line में slide show आ रहा होगा.
जी sir, this is the slide show.
This one.
ये slide show पे चला देना इसको.
जी sir, slide show पे चलाया. Is this not okay now?
First, you have to enable the editing.
Ah, okay. Thank you, sir.
वैसे नजर तो इस पे भी बड़ा अच्छा आ रहा है, कोई प्रॉब्लम नहीं है.
नहीं,
काम ठीक हो
It's
गया,
fine.
फर्स्ट क्लास हो
It's
गया.
fine.
Thank you so much, sir. I'm sorry, I'm a very low-tech person in
नहीं
terms
नहीं,
of
it's okay, it's
computers.
okay.
Thank you. Thanks for bearing with me. So the question is that we still have less than 100,000 samples data from across Pakistan. This is very limited. And the reported number of positive cases seems to be increasing every day, but that does not reflect this increasing or decreasing trend of the actual spread of the virus in the community. It only reflects the increasing capacity. And in my opinion, the coronavirus has spread widely into the community, and we don't really have a realistic data about that. How? I just substantiate my claim that 350 tests per 1 million people of Pakistan is the rate at which we are currently receiving the data come out from all the labs across Pakistan. And model of sampling is foreign travelers to Pakistan, gatherings of local people, VIP samples and frontline warriors, and some random community. Random community sampling has started just today. I saw it in a commercial, and they've started it today. So let's hope it goes further, but the cost is a limiting factor, of course, and there is availability of it. So I'm not criticizing anybody. I'm just pointing out some missing gaps. And the real life evidence suggests that 92 or 93% of the recovery rate reported yesterday by Pakistani official website, which is very encouraging. Alhamdulillah, it looks like we need to find the scientific reason behind it, that how our community is showing greater immunity and recovery rate. And I also see that quarantine wards are not crowded with people looking for critical assistance. This also is a very good indicator of the fact that certainly we need to explore what's going on. And the practical evidence in the quarantine wards, hospital, and the global data, our scientific data from the lab is not concordant with the evidence. I hope you agree with that. The other thing that I think is very important to understand, that we are missing collaboration between our academia, research centers, healthcare setup, and the emergency fighters and bureaucracy. Because this is a mysterious, invisible, and a very lethal weapon that has no eyes, because it doesn't choose to, in fact, poor, rich, or young, or old. It just does it randomly. And it has a brain, because it changes the behavior, it changes the strain, it changes the intensity. The scientific data is very important. With the genomic data from research labs will give us a few answers to a few key questions, such as source of the threat, nature of the threat, like extent of the spread in the spread of the infection, and the types of threats, like the different strains of the virus and their behavior in our community, the epidemiology of the virus, and response to the virus to match allocating resources is very, very important. Our community in the labs, in the research labs, of course, I'm sure they're doing a lot of work, but when we go to the NCBI database or UK Biobank, we see only a very limited data going there. Dr. Ataur Rahman submitted some my previous information, not of today, some like nine sequences, nine sequencing datas, and he reported several mutations, more than 6. But unless we present more data, the scientific community globally will not be able to validate their findings. So it's very important to involve scientific community, the research labs, the people who have the capability of doing sequencing. They must provide the genomic background and genomic data of this virus in our community so that we adopt proper strategies and allocate proper resources. Because doing PCR is way too expensive than adopting other alternative solutions. The certain missing gaps in the PCR testing, Professor Ijaz went very deep into explaining the PCR technology. So let's look at certain gaps that are missing in our community, in our country. Our country, when it just started the PCR testing with the word saying PCR, PCR, and PCR. Real-time PCR or reverse transcriptase PCR, no matter what it is, they wanted the kit. The kits that came to Pakistan first were detecting only one target from the whole genome. Then there came the kits who had 2 targets to be detected with 1 internal control. Then came kits who had more capability of detecting 3 targets, 3 gene targets with 1 internal control. So obviously the specificity continues to vary from a single target mechanism to 2 targets mechanism to 3 targets mechanism. Professor Ijaz also just mentioned that limit of detection is an issue. This greatly relates to strategy adopted across the board. Suppose 10 labs in Pakistan are doing PCR testing. Some of them are using single target based strategy. The others are using 2 targets based strategy, and some are using 3 targets based strategies. Their limit of detection will be completely different from one another. It ranges. The range that I've so far been able to ascertain from various kits, with single target kits, you get no less than 2,000 copies per ml as limit of detection. And the kits employing 3 targets detection mechanism give greater sensitivity and specificity and have 100 copies per ml. So results coming from all the labs are not standardized. They need to be standardized by means of some selection of a mechanism by authorities to streamline and standardize all labs to one methodology. Otherwise, the results coming out of the labs will continue to be debatable and not reliable. And then also, we need to understand the aberration of the technique, which is half-log. This will continue to be there. It cannot be overcome. Half-log variation in the technique has a big effect on the data. Like suppose, for example, today a sample recovers as 600 copies per ml. You run the same sample in the subsequent batch or maybe next morning, it may give you another number, something like maybe sometimes 2,000 copies or more, or sometimes no copies at all on the threshold scale of the PCR instrument. So aberration plus non-standardized testing strategies like single gene or 2 genes or 3 gene targets is providing data which becomes questionable. And missing the serological data results into false negative results and false positive results. So reliability of the data really needs to be addressed very quickly. When we are devoting so much of resources and building so much of capacity for the similar test, so definitely this needs some attention by the scientific community like yourselves, you being the chemical pathologists. I think it's your role to step up and address this issue as well. I've heard that Ministry of Health in Punjab has on 25th of March released a circular asking the members of their committee to submit the standardization protocols. But unfortunately, the meeting could not happen so far due to a lot of the existing commitments and problems arising every day. And putting a handle on them is the basic priority of all the management teams. Now, coming to this slide, where Dr. Ijaz said, can you see this? Can everybody see this slide?
I'm sorry, Mr. Rana, we are very familiar with this slide. Actually,
Yes.
this was part of my first presentation, and then I circulated this as a single pager, and I recommended that this should be part of every PCR report which we generate, so that people should get some awareness of the relationship of PCR with the serological test. I'm very happy that you have also shared this thing.
Thank you very much, sir. Yeah, the only attention I need is on this part of the slide. The test results, PCR, IgG, and IgM, and their clinical significance. These 7 questions are very critical questions and very simplified and explained in a very simplified manner on this slide. Can I address a bit, or should I move forward? Sorry, Professor Ijaz, you're muted.
Please go ahead. Please go ahead.
Okay, thank you very much. I know your time is
yes,
very
because
important.
I had committed 1 hour, and now we have more than that.
I'll just go very quickly. On this slide, if we see that if the PCR result is positive, IgM is negative and IgG is negative, the patient may be in the window period of the infection here. The PCR test is positive, IgM is positive, IgG is negative, patient may be in the early stages of the infection where decisions need to be made. And then PCR positive, IgM positive, IgG positive, patient is in active phase of infection. PCR positive, IgM negative, IgG positive, patient may be in the late or recurrent stage of the infection. Then PCR negative, IgM positive, and IgG negative. Patient may be in the early stages of infection, but PCR results may be false negative. PCR negative, IgM negative, IgG positive. Patient may have a past infection and has recovered. PCR negative, IgM negative, IgG positive. Patient may be in the recovery stage of an infection, or the PCR results may be false negative. So use of the serological testing in parallel with the PCR is really, really important. Now, what we can do is here is move to the suggestions and way forward. In my humble opinion, we need to implement standardized 3-gene in a single 3-gene targets in a single tube RT-PCR testing that will standardize it, be it 1 gene, 2 gene, or 3 gene, depending upon the available resources in the community and the type of allocation you can make. Without standardizing, you will continue to get different results which you cannot compare from lab to lab. Second, use of the external quality control scheme to handle everyday recovery rate in each PCR lab, because PCR technique continues to vary from day to day, from lab to lab. And if you incorporate a control, which suppose, for example, starting material as a value of known copy numbers, for example, 3,000 international units per ml or 3,000 copies per ml. Now, if you circulate that sample to all the labs and they report the results back to the central location, you will see the variations, and then you can easily determine which lab results are safe, which lab results need more review, and which lab has contamination or etc. other problems also. So this is a key area that I would expect to highlight, that the use of external quality control material, which is a certified reference material, will always behave like a human sample, not like an internal control or an in-kit control, which has certain additives to boost the performance within the detection system or extraction system. So incorporation of a third-party, independent, certified quality control material used with serial dilutions for everyday testing as an unknown specimen. All labs will help standardize the results coming out of the labs and provide more information. Starting the serological testing in parallel, like Professor Ijaz said, is very important, and very rightly said that NIH had stopped the use of Chinese devices which flooded the market immediately and could give a lot of false results. It's absolutely right, but now we need to review it, because we are entering the phase where rate of recovery is more than 93%. Last night I was on the Worldometer, and I also checked the website of Pakistan, official website of Pakistan government. Both show the same results. Pakistan is showing 93% of the recovery rate, whereas the fatality rate is going down. So it looks like we have crossed the peak already. The peak period happened somewhere in the weeks of March. I don't know. I don't have valid evidence for that. I'm just providing a tool to look at in a different way.
Thank you very much, Mr. Shoaib Rana. It's a really, really very scholarly and excellent talk. And actually, there is a lot of noise, and I couldn't mute other people's mic, but people are sending me messages that they can't understand more. So otherwise, inshallah, we will continue this discussion. Probably this was your last slide. And
I have one more thing to mention.
Please.
That I'm sorry. Then let's just finish it. That when you are starting to consider the use of serological testing in the labs in parallel to the PCR to be able to ascertain a lot of information like the extent of the spread, the rate of recovery, or safety of people, etc., and the validation of the PCR data, it's very important to standardize methods at the outset. Otherwise, loads of kits, loads of companies across the globe have the products, but their sensitivity and specificity is so broad. Like, for example, the pictures of the ICT devices you just showed in your presentation will have less than 90% specificity. So there would be a big problem with the results that you will not be able to use. Using a mechanism, I don't know which company provides it. I was yesterday looking at the news on the WHO website that there are maybe 18 different companies who have applied for the approvals, and including Biorad also. And they are claiming that they can show 100% sensitivity and 99.5% specificity of detection, plus the differentiation of the antibody, the type of antibody present in the sample will be very, very important. Otherwise, you doing total antibody quantification or plus and minus results will not lead us anywhere. So my humble suggestion would be that the committees should be constituted to look at the offers available globally now and choose the right specificity and sensitivity to be employed by labs across Pakistan. And use of antibody-based tests does not require purchasing a lot of hardware. Every lab almost across Pakistan has the hardware already. They just need the kits. So this effort can start very quickly and provide a lot of valuable information. Any questions?
Thank you very much. Let me wind it up now, because people have already started showing some anxiety. Please now stop this share. Okay. Honestly, Mr. Shoaib Rana, your talk gave us, enlightened us a lot, and some very technical, highly technical points were shared by you, and that added to our knowledge and added to our plethora of information, and really, really thankful to you. And inshallah, this
Thank you very much for
cooperation
allowing me the chance to participate, sir.
will continue. And if any question, just 2 minutes for any more questions. And please, if possible, use. Okay, I have stopped sharing. Now I can see you. Thank you very much.
I'm not a techie person. I'm
Yes.
sorry.
Actually, mashallah, there were more than 50 participants in this talk, and I can see them all in the screen, and I'm making a small picture also. And now you can ask question, just 2 minutes, while I take 1 or 2 minutes.
Assalamu alaikum, sir. Sir, I'm Dr. Shabahat
Dr. Shabahat,
from
please.
Sheikh India.
Ji.
Good to see you here, and it's a very wonderful talk on both parts from you and Sheikh Rana sir. Sir, I have a question. If you please answer it here or afterwards, sir. Sir, I wanted to ask as a chemical pathologist, because till now, the research has shown parameters, the laboratory parameters to look after for the division of the patient to put into isolation or on ventilation or in just quarantine are based on the hematological indices. As a chemical pathologist, like NLR ratio has given us the idea about the stratification of these patients. So as a chemical pathologist, can you guide us?
Yes, yes. Thank you, Dr. Sabat. Actually, you're very right. The hematological parameters are very important, NLR ratio. And lately, there are also other, because now it is said it is more of a toxicity rather than ARDS. And this is because of the dissociation of the hemoglobin, oxygen from hemoglobin, and iron toxicity. So two biochemical parameters are of immense importance. One is ferritin, because ferritin is highly important parameter because it is raised because of displacement of iron from hemoglobin and because of its acute phase reaction. And second is lactate dehydrogenase, LD. LD gives you an overall picture.
It's a marker of increased cell turnover.
Pardon? Pardon? Dr. Swat, क्या कहा आपने? What you said?
Sir, मैं ये कहना चाह रही थी कि both of these markers are there. Ferritin, of course, अब जो shift हो रहा है कि it's not ARDS, a case of alanization of membrane. It's basically the toxemia, actually the toxication of the hemoglobin, like methemoglobin, lowering capacity of HB to carry the oxygen now. So instead of putting them on the ventilator or giving the 100% oxygen is not the answer. Rather, the fresh transfusion or the plasmapheresis could be the answer to this crisis. So, as an independent parameter, like I say, LDH again, the specificity is low and the ferritin has to. So why not go to the methemoglobin or that some level? It's just I'm asking for the guidance.
Yes, so, there is another parameter, procalcitonin. Its importance is to detect any co-infection, co-bacterial infection. So you can advocate this also. About methemoglobin, yes, please, what you say?
Aamir, can I make a comment here?
Please, Dr. Aisha, please.
Procalcitonin is also being used in some situations like this one. People are using it, procalcitonin, but I don't know, I'm not aware.
Yes, I just told you that procalcitonin is used to detect or find any co-bacterial infection, because procalcitonin is a marker of bacterial infection. So they recommend it periodically so that they can know whether there is co-infection by the bacteria or not. Now coming to the methemoglobin, I really don't know about it, and anybody can read it and later on place some information in our.
Thank you. Thank you very much, sir. Thank you. Thank you, sir.
Any last question? Now the last question, because we are overshooting.
It's not the question, is just to thank you. Thank you very much, Aamir.
Thank you. And now the job is of Mahin, my son. He will have to do a lot of editing probably. And again, he will say that there are some problems. Okay, thank you very much. And it's an ongoing process. You should share information, you should share your knowledge, and you should share your queries in the forum. And please, please tell other people also, don't share general things on this forum. religious things, sectarian and jokes. Please stop this and just use this for the purely information regarding COVID or information related to chemical pathology. Thank you very much. And I now close the session and hope
Thank you.
Allah bless you all and keep you safe.
Thank you very much, Dr. Asim. Thank you very much, everybody. I've shared this presentation with Dr. Asim already. Dr. Asim, please share it with everyone.
Thank you very much, Chef.
Correction